This conference will now be recorded.
So today we'll understand about some of the basics of data science. We will try to, in the previous session, we were looking at end-to-end understanding of data science. Today we'll look at some of the basics of data science, and in the coming sessions we will look at some of the applications of data science. So let me open up a small presentation. So data science or data analysis as a concept was there for many years. No, it is not like the new one. It's not like a new thing, like say like quantum computing or something like that. Just a second. Just a second. Yeah. So data analysis has been there for quite a long time. It is not like a new field like IoT or quantum computing or any other field which is started recently, right? Uh, Data science and data analysis, there were a lot of experiments done in the past, uh, dated as back as 1935. There were a lot of systems which were created in terms of business analytics, exploratory data analysis. New fields emerged in the field of machine learning, and there were some popular books and theories written. One of the popular book on machine learning is used as the uh, is used as the only book for teaching machine learning in many of the academias, written by Tom Michel. And if you take the companies and different paradigms which were run, all those things as depicted like how data analysis proved for taking the data, analyzing it, and showing some insights to the business users. It was there for very long time, right? So what we are trying to see here is, the data analysis has provided a lot of insights for our information. But something has changed in the current few years, like which has actually provided this huge influx in the applications which are created in data science, machine learning, deep learning, and so on. Before that, we have to a little bit understand about the the AI winters which happened in the past few years. So what happened is 1958 or so on. So in the year 1958 or so on, the initial models into the data analysis, typically the AI models were created. They are called as perceptron models. The perceptron models were very popular in creating the understanding of how do we take the machine related knowledge and try to make decisions like yes or no decisions. Back in those days, it was very uh, in the initial stages, and people thought that this is going to change the world. And the perceptron models did not last for long, and it went into AI winter. AI winter is a phase where, like, after a hype cycle, it went into a slowdown. That is called as an AI winter. So from a from a stage where there was a huge hype, it went into a valley. So such kind of applications, they we can call it as the AI winters. Again, there was again a hype somewhere in 1980s to 90s where people started creating human visual related applications using AI, like how do we detect handwritten digits or identify objects, and such kind of applications were developed. And there was a lot of research in the space of CNN models and so on. Again, there was a second hype, followed by the second AI winter. Now, why did the first AI winter cost? We need to know, like, why did this first AI winter cost? This AI winter cost because of unavailability of data. Unavailability of data. The first AI winter cost unavailability of data, and the second AI winter cost because of because of unavailability of compute. So I can say no good compute, right? Unavailability of data, which is like you know the data was not available, and we were not able to store the huge volumes of data and so on. So that was this unavailability of data, and unavailability of storage capabilities. And the second one was, even if we have right amount of data, we have storage solutions for to store right volumes of data. Second one involved in no good compute. So we did not have the right amount of CPUs, GPUs, and other kind of systems which can process this data. So that was the unavailability of data and unavailability of compute. So now we are in the phase like 2009, 2021. Uh, Maybe if I draw a line here, so we are like 2021 or something like this. So we are in a phase where we are trying to decide whether it would again go to a AI winter, or it would be sustaining, or there will be a huge adoption. People are kind of deciding. See, what my perspective is, there are three things which came into like a combination, which is causing a good sustenance of the AI technologies. First one is the big data. Now, the big data, we talk about huge volumes of data, huge volumes of storage capabilities, and so on. So now with the variety of data like images, videos, censored information, text data, structured, unstructured informations, all those things are now available, and we are also able to store those huge volumes of data. So thanks to big data. Second one is the cloud computing. Now, TI. The second one is the cloud computing. The cloud computing is nothing but cloud computing is nothing but what we are trying to see here is the different systems which are available for storages and computation. So instead of having systems on our local machine or on premise, now we are leveraging the power of cloud computing, so that we can have a distributed computing somewhere else in the world, where we will be having good amount of CPU, GPU, other kind of compute capabilities. We have large volumes of storage capabilities, all of them connected in a network, and we will be able to use those facilities for running our experiments. So thanks to cloud computing, and because of the cloud computing, we are not having this second issue. The first one, big data, was kind of solving the first issue, where we have huge volumes of data, and we are also able to store huge volumes of data. That is the first issue. The second issue is the compute issue, where even we have data, we were not able to having the right compute because we are not having the right GPUs and so on. And that is being solved by the cloud computing because we can use the distributed computing paradigm here. So instead of having a local server, which is like on-premise where we are purchasing the server and doing all the things, we are now, renting out from a cloud provider. Cloud provider could be AWS or Azure or any other kind of cloud provider. So that is what they are doing. The third one is basically third one is basically the algorithms. So there are a lot of algorithms now which are available, and a lot of people have created these algorithms, which can help us to do a lot of analysis. Now, over the period, people have developed a lot of algorithms which can make use of the cloud computing and huge volumes of data and can extract large volumes of and can extract large volumes of information. So that is becoming very, very evident these years. If you see in 2017 and onwards, people have created very good frameworks. For example, there is a framework called as TensorFlow, which was released by Google, which actually is the base for doing a lot of deep learning work. Deep learning is about using uh, uh, large volumes of unstructured data which are very difficult to process, like images, videos, and textual data, and so on. So for those algorithms, there are a lot of good frameworks which were created. TensorFlow is one of them, and we also have another framework called as PyTorch by Facebook. So these good companies, what they are doing is they are open sourcing their algorithms, which are used for their cutting edge technology. So the same algorithms can be used elsewhere, maybe in an agricultural domain, or maybe in a manufacturing domain, or in a retail domain, to do a lot of processing of that data, which was not possible uh, for analysis prior to this. So those availability of algorithms also played a lot of game here. So all in all, what we are trying to discuss here is the availability of big data, availability of storage of big data, then cloud computing so that we can use a lot of newer and distributed computing platforms, then the algorithms which help us to run on the data on these cloud computing platforms. So that combination of all of these is crucial for the sustenance of this technology. Now, according to me, I'm not going to say like, okay, this is going to go crazy, but there are a lot of good applications we are seeing, and I'm very positive that there will be a lot of applications in the coming few years which will use these technologies. Some of them are becoming mainstream. For example, you see voice-based commands like Alexa and other things are becoming mainstream. People are trying to create a lot of applications which will be integrated with the voice-based commands. You say, "Hey Alexa, what is the weather today?" And you can also ask some other details like, where did I kept my keys or whatever, right? So a lot of these things are becoming mainstream, and they will in the future. You would also see that you get all the services and facilities by these applications. So what we observed here is that data is everywhere. Huge volumes of data is the prime reason for this kind of systems to be created, because this data is growing at an enormous pace. The data which is generated is helping us to do a lot of these applications. Now, this is a little old slide, 2018, but now even in 2020, 21, we are seeing that there's huge volume. So the graph is growing like this, and there is a huge volume of influx in the data. Now, when I say data, what does this data represent, right? From a business standpoint, the first and foremost data is called as transactional data. What is a transactional data? Transactional data is nothing but in everyday business. So if I am a retail shop, the product sales and how many products are sold, what is the price of the product, who purchased the product, how many products did they purchase. See, all this information is called as transactional data, right? If you are a bank, like how was the money transferred, how much was transferred, did the proper reconciliation happen, and all that stuff, that is called as transactional data, right? So the transactional data is basically the data which is used by the all the companies, the brick and mortar companies, the manufacturing companies, banking companies, and likewise all these companies are being used for your transactional data. So those data traditionally is stored in systems like RDBMS databases, where we can retrieve the data, and that is used for doing all these queries. So we might create some SQL queries for querying the database and can get the insights of the data, like how many products were sold in the last month, and what is the yearly sales, what is the monthly turnover, and so on. Likewise, we can get all the insights. Some of the other examples of data is audio data and experimental data. Let us take about audio data. Audio data where we are seeing that we are trying to use our speech for triggering some kind of actions using audio devices like Alexa and so on. For example, I say, "Hey Alexa, what is the weather today?" Then Alexa first has to understand what is the speech, who is speaking. So there is a concept like speaker detection, and then after that it should understand what is the speech, what did the person speak. If you remember in the earlier years of release of Siri and Google now and other ones, uh, they used to work pathetically. It doesn't used to recognize the voice of some of the non-native speakers, right? A non-English speaker speaking, it doesn't need to, it didn't, it used to detect something else, right? So it used to be very pathetic back in those days, but now it is it is matured enough, and it can understand even if a kid speaks something, right? So such kind of devices over the time has learned a lot because of huge volumes of data. They have huge volumes of data based on which the training happened, and now they have learned all these patterns for analysis, right? That's how it is. And the audio data is basically that huge volumes of data is being created, and those data, if I am speaking with Alexa, there are certain stages. So first one, when I say what is weather today, it needs to understand the speaker. Second one, it also needs to understand what was spoken, like what is weather today. That will be converted into text. The text has to go to the query engine. Some query engine will be there, like Google and so on, so that we want to find out the weather today. Then, imagine we are getting like 32 degrees centigrade or whatever. So that again, the text has to be converted back into speech. Maybe like some speech, text to speech systems will be used. So overall, that entire application is having multiple sub areas, but the prime area, whatever we are focusing here, is about the audio data. How do we take audio data? How do you perceive that audio data? And then convert into text and then run queries and then get back the results. This is the first one. Second one is the experimental data. Experimental data talks about now we use something called as inferential statistics here, where we try to take some samples of your data, and based on the samples we try to conduct some experiments and extrapolate the results. Now the reality is that the population what we are working on will be huge, and we can't test our hypothesis on the entire population. So we generally do something called as sampling, which is like take a portion of your experiment data and then experiment on that. And then if it works out fine, then we extrapolate those results to the actual population. So if you take the example of our deadly coronavirus, the case of COVID-19, so imagine people were trying to create vaccine for COVID-19. The way it is tested is first you will identify like 1,000 patients. Imagine that is the population, and then out of these 1,000 patients, we will try to randomly sample around 100 patients and test your new vaccine or maybe the drug on these 100 patients. Imagine we want to release a drug for COVID-19, which will completely eliminate or even reduce any of the impact. Then you have to conduct this experiment. So the experiment will be conducted on the 100 patients, and if it is working fine, and if it is curing the patients and having good amount of relief without any side effects and other things, then what it will do is it will basically we can extrapolate that results to the actual population, right? So we can say that because this drug is positive, it is curing the patient, it is having good relief, no side effects and other things, then we can extrapolate that to the actual population and say everything is good. But that is experimental data. Next one is video and image data. The video data is basically the way we are taking videos. And first we'll talk about image data. Excuse me. Apologies. So got a little cold. So we're talking about image data. First, we'll understand about image data. There is a lot of these image data analysis which is happening in various industries, healthcare, media, manufacturing, then retail. These are all the different industries where we are trying to analyze these images and try to take some decisions based on image processing. One of the good example we can talk is on diabetic retinopathy. If you have seen Sundar Pichai's Google I/O's Google I/O's conference talk, he was especially explaining about this particular application, which is called as Verily, which worked on something called as diabetic retinopathy. Now, diabetic retinopathy is a disease where, like, if your diabetes levels are going up and slowly you will lose your eyesight. And there will be some cotton spots or swabs kind of things which will be formed in the eye, in the retina, and slowly as the time progresses, the person will lose the eyesight. If it is not detected at the right time and medication is not taken, it is, it will kind of cause a lot of problem. And it is curable also. So if it is detected at the right time, provided right amount of medication, it can be cured. So diabetic retinopathy was a big problem in India. And what they have done is they have collaborated with two primary hospitals. One is Shankar Netralaya and second one is Arvinda Eye Hospital. And both those hospitals, what they have done is they have collaborated with them, and then they have created their apps. There is a application called as Verily, which is provided to them, and using Verily we can take snapshots of pictures of our retina, and it will identify whether it is prone to diabetic retinopathy or not. If it is identified as a diabetic eye, then it will give the indication saying that where the diabetes is and where it is identifying the spots and other things. And based on that, the doctors can take uh, some decision making right there. Patients will be identified well in advance so that they can start taking any medications and so on. That is called as diabetic data. The second one is the video-based analysis. Now, video-based analysis goes one level higher because video is nothing but continuation of frames. Now you can say 24 frames per second, 30 frames per second, 60 frames per second, and so on, right? So what does that mean is like per second we will have so many frames running. So 24 frames per second means when the second passes, you would quickly run 24 frames through the through the course, which will give us a intuition that it is having a motion kind of an action in your uh, for us, like for our human eye, it tries to give that intuition that it is having the real motion, but that is happening because we are running 24 frames within a second, one after the other. And it can go to 60 frames per second. These are some of the normal frames, and based on that the video is created. So if I want to run the analysis on video, try to determine suddenly, like, I wanted to identify whether the person is wearing mask or not, right? So there is this attendance system in the company, and they are having the CCTV camera, and they are looking at the CCTV camera of people who are entering the company. And if the person is wearing the mask, then the doors will automatically open, right? If the person is not wearing the mask, the doors do not open, and they have to mandatorily wear the mask, and probably it might give a indication that please wear the mask and come inside, right? So such kind of applications can be created. What they are doing is they are looking at people's faces and trying to determine whether the face is a normal face or a masked face. Masked face is like people who are wearing masks. So if a masked face is identified, then we can automatically trigger systems which can open up the doors, or we can trigger a system which can give a indication to the speaker, which can talk about, please wear the mask and come inside. A lot of systems are created which are combinations of image and video data, and using it we are trying to create a lot of applications. Another areas are these pictorial representations of graphs and charts and other things. So how are these graphs and charts and stats created? Those are different applications which are created, and these graphs and charts and stats, what happen is, like, they represent how your data is, how your data, what is your data talking, right? So instead of just giving some numbers to our higher officials, if we can represent those numbers in terms of these graphs and charts, and which gives us a very good very good insights about how these different data is represented. So there is a lot of analysis on how do we create these graphs, how do we represent the charts, and how do we deduce these stats from the charts. So all the things also are some type of data. So before getting into the real applications of data science, now there will be a small question to be answered, like what is artificial intelligence, what is machine learning, and what is deep learning, and what is the relation between data science and all these things, right? So if you are familiar, there is a place in Hyderabad. So I am a resident of Hyderabad. So there is a place in Hyderabad called as Amirpet. So people call that as the education hub, or probably training hub or something. Okay. So whenever there is a new course, then you get a banner stating that 10 or 20 years of experience in so and so course. And what do they do is they have banners for everything. They have banner for artificial intelligence, they have banners for machine learning and deep learning and data science, four different courses. So people run like that, and then whoever is taking, they get confused that, are they same or are they different, or what is that relation? And many people ask me in the initial stages that, no, can you kind of let us know like what is what? So I think this few minutes will try to deduce that understanding, like what is AI, ML, and DL, and the relation between data science and so on. So AI in the initial years, what people decided is, can we do something which, you know, a machine can do so that humans will be relieved of those tasks. So that was the primary thought. And uh, things like which were monotonous, which were which can be automated, right? So such kind of things were created as rule engines. So you create some certain rules of daily tasks which were very monotonous, performed by humans right now, which can be automated. So such kind of tasks, what they have done is they have created some set of rules, some set of logics and other things were created, and based on those rules and logics and other things, uh, computer programs were written so that instead of a human doing that work, computer can do that work. Okay, that was primarily turned to be as a artificial intelligence. So you can think like artificial intelligence is an umbrella which is kind of governing the base concept of how to make computers do the work of humans. That's the reason it is saying artificial intelligence. So it's not natural intelligence, it's an artificially induced intelligence by humans who are intelligent. Now, how do they get that intelligence? By experience, by practice, and a lot of other things. By looking at the practicality, and based on that, we are trying to create some set of rules and logics and decision-making conditions and so on. Imagine, imagine I'm working in a company which is trying to make some carton boxes. So you have these packaging boxes for Amazon, Flipkart, and eBay and other ones, right? So I want to create these packaging boxes. I'm having all workers who are kind of taking a cardboard and kind of turning it. So imagine I was given a piece of cardboard like this. So first I'll turn this side and turn this side, then turn it around, and I do all these shifts and turns, and then finally I'll create a box like this, right? So this entire so the box will be created something like this. Then the twists and turns will be created, and then finally the box will be created like this. This is a regular task done by humans. If I want to automate this task by putting some rules, what you will say that is, you take a piece of cardboard, then first rule is, okay, turn it turn it maybe one third and turn it to the left, and take the other one third and turn it to the right, and other one take turn it to the left and right, and then finally the box will be created like this. So you can set the rules and give the rules to an automated machine, a robotic arm or something, which will then apply all these rules and then create this box. So this is a typical example of artificial intelligence. Now the same artificial intelligence is also created in process. There is something called as robotic process automation, which is a process related automation. And the same kind of automation is also in software, which they call it as automation, but it also falls under AI. Okay, the same AI umbrella. Now this is good. Like humans are giving the logic, humans are giving the you know decision making power, or other kind of rules, all these sets of rules and concepts, steps, whatever. So all these things are given by humans, like some SME is there, some subject matter expert who is providing all this information so that this kind of action can be taken. That falls under AI. But what if I have huge volumes of data and I can't understand all the rules? Like there are 1 million rows and some 100 columns are there. So it becomes very difficult for a human to deduce those rules. So can we take help of algorithms which can help humans to deduce the rules? Yes, we can do it. That is called as machine learning. So machine learning is a subset of artificial intelligence, primarily creating those set of rules and steps for automating certain things. But instead of humans providing those rules, we are taking help of some statistical techniques. Some statistical techniques will be used so that the machines can, conduct those experiments and create those rules. So those rules will be used for doing future predictions. Imagine I am given like 1 million records of all the customers who have applied for loan in the past 3 years, and there are like 100 different columns of these customers. Then from those data points, I have to create some set of rules which can be utilized for the next set of customers who are applying for loan. So I have to create that algorithms so that I will create something like a model or an extract or a formula or something like this, which will be used for predicting the next set of users. That area is called as machine learning. Now there is another area which is called as deep learning, which is a subset of machine learning. It is one algorithm of machine learning which is called as artificial neural networks, which is given a name called as deep learning, and that is used for deducing the that is used for predicting even more complicated data which is involving in speech and image and text and other kind of things are even more harder. They are unstructured in nature, they are even more harder to detect, and for such kind of algorithms, artificial neural networks are used for running on vast majority of data, and they are used for prediction, right? So you guys understood artificial intelligence is a umbrella, or it is a major area primarily focused on creating systems which can make the life of humans easy by taking the monotonous task of the humans and making the machines do that work. The same work can be done by machine learning, but the thing is that when the data is increasing, you can't just have a human create all the set of rules. So it becomes very difficult, and machines are used for identifying the statistical data points. So using all the statistical techniques and algorithms, we are kind of creating that rules. Deep learning is further set of sub machine learning, which is a one algorithm of machine learning, which is called as artificial neural networks, which is specialized in working with images and other speech related data and so on. Now people will ask like, this is good, sir. I understood what is AI, ML, and DL. Then what is data science? Now data science is the connecting piece. For example, we understood that this entire area is the central piece, like the algorithm part. But somebody should give data to it, right? So there are some data ingestion systems. So somebody should give data to it. Now, when they are giving the data might not be in a right format, so somebody should process it. So there are some data transformation systems. Somebody should care about the storage. Somebody should care about, model development. Model development. Somebody should care about data visualization. Maybe in the earlier days, we can also call it as exploratory analysis, right? So we have data ingestion, data transformation, data storage, exploratory data analysis, and model development and data visualizations. Likewise, we have different kinds of connected pieces, right? We are seeing now there are different kinds of these connected pieces which are connecting all this entire area from start till end. That is called as data science, right? So we are learning data science, like how do we ingest data, how do we transform it, what is the storage available, what different types of analysis which is performed for analyzing the look and feel of the data, exploration of the data. Then we will apply the algorithms either by machine learning or rule based or uh, using deep learning. Then we will try to create some model development. We can use it for deploying of the models, and then we can also use for visualization of the results and so on, right? Understood? Any questions on what we discussed today? Is it clear? We were trying to create a very base for our analysis. We are trying to see like how different types of data is used, and what is the prime difference between AI, ML, and DL. Any questions? You can use the chat window or you can speak up, ask. All right. In the next sessions, what we are doing is we are trying to understand what are the different applications of data science. So there are a lot of applications of the data science in the social world, image-based analytics. You are using different kinds of other application areas. So we will cover different applications of data science in the coming few sessions. So in tomorrow's session, we'll start understanding about what are the applications in the banking space, applications of data science in the insurance space, social media analytics space, and all those things we will cover in the tomorrow session. All right. If you don't have any questions, we can close it here and we'll come back tomorrow, same time. All right. Thank you very much. Have a nice day. Bye bye.